So nuclear fusion is essentially very similar to nuclear fission. Still have the same forces applying, where you've got the electromagnetic pushing apart, the nuclear force pulling it together. It's when two small nucleus fuse together to make really big, or not really big, but bigger nuclei. So you've got two atoms coming together, making a bigger atom. Nuclear fusion is the most important reaction in the solar system. The Earth would not exist if not for that. Well, the Earth would exist, but there'd be not a lot going on. So the reaction that powers our sun is nuclear fusion. If you remember from year 9, what takes place? Hydrogen becomes what? Helium. Okay. And in that reaction, the products have slightly more mass than the reactants. Again, very, very small amount. The 1 gram example that I just gave you was way too big, but not to the sun. The sun loses the heat more than that. But in that equation, we again use E equals mc squared. What's the problem with nuclear fusion on Earth? Because humans are trying to use nuclear fusion as a power source and various other things. What's the problem?
The radiation that comes off.
Yeah. There's no dangerous waste with this. With fission, there's nuclear waste issues, not with nuclear fusion.
The heat it gives off.
It does give off a lot of heat, but that's not the problem. That's what we're looking for.
It's unpredictable and can cause chain reactions.
They can't get the heat and pressure required.
Correct.
Oh, yeah.
The problem on Earth is that it's very, very hard to create scenarios where the small nucleus travel fast enough to overcome. Because what happens if you bring two positive things near each other? They repel. So to get the nuclear fusion, you've got to have a high-speed, high-density collision. And that occurs in places like the sun because the sun is monstrously large. Got lots of particles in a small... What's the hottest part of the Earth? The outside or the centre? Centre, because you've got all that pressure and all the particles on the outside pushing in. Same thing applies in the sun. You've got a heap of pressure jamming atoms together. On Earth, we struggle to get atoms to that speed, or nucleus to that speed. And the only way we can do it, well, there are a few ways, but one of the ways we can do it is using nuclear fission. But the problem is we put more energy in than we get out. So we have to put more energy into getting these things to collide than we can get out of the reaction.